Hello everyone and welcome back to our videos. Today we are gonna talk about pressure. General book chapter 2 physics. Pressure is the measurement of a force exerted on a given area and is usually expressed in pound per square inch, or it can expressed in inch of mercury or millibars. Here we have the atmospheric pressure or sea level pressure. The atmospheric pressure here is standard, and here we have 14.7 part in pound per square inch. And the second one we have 29.92, but the unit is different here in inch of mercury. And the last one we have 1013.2 millibars. We can differentiate between the atmospheric pressure by their units: pound per square inch, inch of mercury, and millibar. After that, we are gonna talk about the types of pressure. We have three types of pressure: the gauge pressure, the absolute pressure, and the differential pressure. What they are means that what we are gonna talk about. The gauge pressure is the pressure read directly from the gauge by its name gauge, so that it's the pressure that you will read it on the gauge. The second one is the absolute pressure. Absolute pressure, we can define that the absolute pressure is a gauge pressure plus atmospheric pressure. So we can do it like this. We have the gauge pressure and added with the atmospheric pressure. And the atmospheric pressure, as we studied, 29.92. For example, plus the read pressure, it will be 13. So the sum of there, it will be the absolute pressure. So when pressure is referred or is referenced from zero pressure rather than from atmospheric pressure, it's known as absolute pressure. So you can make two definition for the absolute pressure. You can say is referenced from zero pressure rather than from atmospheric pressure. Or the second one is the absolute pressure is the gauge pressure plus atmospheric pressure. The third type of pressure is the differential pressure. Differential pressure is the difference between two pressures. How that's come? We have an example. The difference between the ram air that enters the pitot tube and the static air pressure. Here we have the pitot tube of the aircraft, and the pitot tube, it will make the differentiate between the ram air pressure and the static air pressure. So the difference between them, it will be our differential pressure. Again, the differential pressure is the difference between two pressure. Like here we have the pitot tube. The pitot tube will make the differentiate between the ram air pressure that will enter the pitot tube and the static air pressure. Now we will talk about gas laws. Here we will talk about the Boyle's and Charlie's law. Gas and liquids are both fluids that are used to transmit forces, as we studied before. However, gases differ from liquid in that gases are compressible. The gas, it can be compressed, but or while liquids are considered to be uncompressible. This is the difference between the gas and liquid, but they have the same function. They will transmit the force. The volume of a gas is affected by temperature and pressure. The degree to which temperature and pressure affect volume is defined in the gas law of Boyle and Charlie's law. So our laws, it will talk about the relation between the volume, temperature and pressure. And we will start with Boyle's law. Boyle's law. In 1990, the British physicist Robert Boyle discovered that when you change the volume of a confined gas that is held at a constant temperature, the gas pressure also changes. For example, using Boyle's law, if the temperature of a gas is held constant and the volume decreases, so the pressure will increase. Volume and pressure are said to be inversely related, and the relationship is expressed in the formula V1 divided to V2 equal to B2 divided to B1. The V1 is the initial volume, V2 is the compressed volume, P2 is the compressed pressure, P1 is the initial pressure. Here we have an example. The example said, if 6 cubic feet of oxygen is pressurized to 1200 psi gauge, what will the pressure be if the oxygen is allowed to expand to 10 cubic feet? We will write our formula V1 divided V2 equal P2 divided P1. Here the V1 is equal to 6 cubic feet. V2 is equal to 10 feet. What about P2? P2, that's what we need to answer it. The P1 is equal to 1200. Here we have our formula. 6 divided 10 equal to P2 divided 1200. We will make our answer by multiply the numerator by denominator. After that, it will divided by 10, and B2 it will equal to 720. And as we talked, the volume and the pressure has inversely relation. So since the volume increased, the pressure must decrease. The new pressure is 720 psi gauge.